this video, we're going to explore a little bit more about the production possibilities frontier. So I've got two examples of production possibilities frontier. And for this first one, we're going to take a look at, let's use just a food example and say that Bob could either catch fish or he could trap gophers. All right, so those are his two options. So he's either going to produce fish or he's going to produce gophers. All right, so let's say, fishing is all that he does and he dedicates all of his resources and time to fishing. And the most amount of fish that he could catch would be 10 fish. So this is the most amount of fish that he could catch. But let's say he switches over and he doesn't want fish. He's just going to try and trap gophers. And let's say he dedicates all of his time to doing that, and the most that he can catch would be 20 gophers. Well, in this sort of scenario, we're going to say it takes, let's say 2 hours of time to catch one fish. And over here, it only takes 1 hour of time to catch one gophers, right? So he can catch twice as many gophers as he can fish because it takes 2 hours for him to catch a fish, and it only takes 1 hour for him to catch a gopher. So what would happen if he decides he's at this point right up here? Let's say he's at this point right here. What would happen if he decides, you know what, I actually would like to catch a gopher? Well, let's say I would like to catch 2 gophers, right? And so he takes plus an hour over here, right, for gophers. And so he's caught 2 gophers. What does he have to do in order to catch those 2? Well, he has to lose 2 hours over here, which means he loses 1 fish. So what point is he at now? Well, he's at this point of, we'll call it like 2 gophers, but he's down to 9 fish, right? And so he's at kind of this point, we'll call it right there. What about if he wants to catch another gopher or 2, right? So he, let's say, adds an hour, right? And so he gets another 2 gophers. Well, he loses 2 hours over here, and he's one less fish he can catch. So he ends up being at a point of, let's call it right here. He's at 4:8. Now, is this ratio going to change ever, right? So let's say he's at, he's at one fish. How many gophers would he be able to catch? Well, he'd be able to catch a maximum of 18, right? And if he loses this 1 fish, he is able to gain 2 more gophers, which would be at the 0:20 point. So there's just going to be this line that looks just like that. And to the best of my ability, it's supposed to be this very straight production possibilities curve, this very straight production possibilities line, this frontier. All right, so this is a straight PPF, production possibilities frontier. So what does that mean? That means the opportunity cost is constant, right? So this is constant opportunity cost. So what's the opportunity cost for every one gopher? What's the opportunity cost for every 1 gopher? If you were to make 1 gopher, if you were to produce 1 gopher, catch 1 gopher, how many fish does he have to give up? Our answer to that would be half of a fish. Well, what's the opportunity cost for 1 fish? Right, so for every 1 fish that he produces, what's his opportunity cost in terms of gophers? We looked at it up here, right? How many gophers was he able to gain with each fish? Well, the answer would be 2. And we'll look at more of that a little bit later. But what you want to look at is how many do you have to give up in order to gain some of the other one? Okay. All right. So that's one example of a constant opportunity cost. And why is it like that? Because catching the resources used to catch fish and gophers are going to be roughly the same. But if we use a different example, and you go back to kind of an example we were doing originally, and we were to say that instead of food, this is actually, let's say, food, and this is shelter. And these two resources are quite different, right? So it takes different types of land, labor, and capital to produce food and shelter. So they're very different. So instead of constant opportunity costs, what we're going to see is this idea of increasing opportunity costs. All right, so let's look at it like this. Let's say that all we are producing is food. So we're at this point right up here for food. And so let's call this 20 food right over there. And so in order to make let's say we can produce 1, 2, or 3 shelters. So 1, 2, or 3 shelters. So let's say we're going to make this first shelter. How much food do we have to give up? Well, we were producing only food. And so even things that weren't good at making or producing food or catching food, lumber that would be actually really good at making a shelter, that was actually going into food production. People that were better at making shelters were actually going into trying to produce food. So in order to produce this first shelter, we don't have to give up very much food because that stuff wasn't even that good at making food anyways. So we lose a little bit of food, but not a lot in order to gain this first one. So we're going to have a point that's somewhere like that. So at a very small opportunity cost, right? So that arrow, that's a small opportunity cost for that first gain. And then in order to gain the second one, we have to switch over more of the stuff that is actually pretty good at producing food. So let's call this one 19 right there. We only lost 1. Now, in order to produce that second one, we have to take a lot more stuff that actually was pretty good at making food. So some of the people that were good at producing food and some of the resources that were good at producing food, we got to take a lot more of that. So let's say this drops down to, let's call it 11 right there. So for 2, we were at 11. So we dropped 1 for this one. We dropped 8 for that one. Right? And then for this last one, we dropped 11 for that one, right? So our opportunity cost went from 1 to 8 to 11. And why that matters is because our curve looks different. We have this bowed out production possibilities curve, right? So it looks just like that. And so that is showing is it's showing that our opportunity cost for each additional good went up. Right, so our opportunity cost was 1, then 8, then 11. So this is called the law of increasing opportunity cost, and it exists because the resources used to produce these two different goods are very different. All right, the final thing I'd like to do on this video is just to recap or review one more time the things that would shift these curves. So if we reset up our production possibilities frontier, and we do a bowed out one or a flat one, doesn't really matter. And we call this food. We call this shelter. Again, I'm gonna write a few things down. I want you to try to answer as before I go through it. So point A, how would you describe point A? Point B, how would you describe point B? Point C, how would you describe point C? How would you describe line D? How would you describe line E? My final question is, what's the difference between E and B? All right, so let's answer some of those things. You can pause and try to figure those things out. Good questions to try and figure out. But how do we figure out some of this stuff? Okay, let's start with A. So point A, not possible. Not possible with our original line. Okay, not possible with our original line. Our original line is this blue one. Not possible with our original line. Why not? We don't have enough land, labor, or capital available. We can't have more of everything. So it's not possible. Point B, that's possible, but it's inefficient. Why is it inefficient? Because we're not utilizing all the land, labor, and capital that we have. We could produce more if we were to choose to produce more. C, that's at the maximum. Any point along the line is at a maximum. D, that's a shift of the PPC or PPF. It shifts the whole thing outward. Why would that take place? That's the main one here. Why? Because we gained more land, labor, or capital. Right? Something made more possibilities in all scenarios of food and shelter. And then let's see, E. What would be E? So E is a shift as well. Why? Because we lost land, labor, and capital. And the last one was, what was the difference between B and E? Right? Well, B is we still have the same max. So same max, right? We're just not using all of the resources that we have. We have the resources, we're just not utilizing them. What about E? E is we have a lower max. We actually have less resources. Right? So we actually have less resources than we did before. So there's a big difference between B and E. E, the whole thing shifts inward. B, we're just at a point inside our maximum line.